Sorry, you're muted. I'll find it and post it.
Okay, no, I was just wondering what the date was if you happen to know it, but that's fine. Yeah.
The date is November 10.
November 10th. Thank you.
Yeah. They're doing a series of announcements of products and features on November 9th, and then the 10th they're having the talk. Assuming the country is still around on that date.
Ouch. Okay, so moving on from that. So fantastic. So people know I am recording this. If you can also mute yourself if you're not actually speaking. And Jen, you're up first, right?
I am up first.
Yay, wait, we got to play the, what's your walk-in music?
Let's go for the Superman theme for 200.
Okay, well, you don't have it queued up, so we'll just have to imagine
Maybe
it.
you can sing it for me. I'm just kidding.
Yeah. All right, so do I need to do something to make you?
No, I have the green button.
Okay, good. Take it away, have fun.
All right, so let me click share screen. Well, before I share screen, for those who don't know me, I'm Jen, and I am the head of technical innovation at Audible. And one of my first projects when I stepped into this role was to make live video streaming available for our listeners via our multiple surfaces, so web, Android, iOS, and Alexa-enabled devices as well. So I'm going to show you how easy it is to bring this into your lives.
A quick side note, people, not everyone is aware, but Audible is an Amazon company.
It is. Oh, I just clicked share screen and now it has options I've never seen before. All right, everyone cross your fingers. Open system preferences. Why is this not working? Have you had a problem?
Yes, I have. So you're going to have to go in and enable a whole bunch of things and then restart. So it's going to drop you, and it's so much fun. I had an update today too, and I haven't been able to share today. But I had it happen a month ago and fixed it.
I'll be right back.
Okay.
Talk about something exciting.
We'll talk
Jazz
amongst
hands.
ourselves.
Everybody jazz hands.
Make sure you enable the accessibility one too, because there's an accessibility one, and if you don't have that one also, it won't.
We'll all just sing the Jeopardy song while we wait.
This is hilarious. Like updates and it breaks everything.
If only we had some IT people to help us out with these things.
I don't see it listed under allow apps to control you. Oh wait, I just saw it. Oh wait, it went away.
Hey.
Oh, there you go.
Wait, that's not me.
That's Brian.
Yeah.
That's Brian.
I was
Brian, you're muted.
Okay, now you have to present Brian's.
Wait, I still need coaching. Accessibility, so I add Zoom.
Yeah.
All right, everyone, you're seeing this happen real time.
Maybe with Zoom it won't make you log out and come back in again. We'll see. Teams is not nice.
It pretty much said I had to.
It's pretty awesome that we're recording this.
All right.
Don't edit the recording, by the way.
I work in tech, I swear. All right, I'm gonna just restart Zoom, hopefully. I'll be right back.
Okay.
I love that assumption. You know, it's like people say, well, you're an IT guy, you should know how to fix this. I'm like, yeah, but I've never worked with that machine before.
The number of times my relatives have asked me to fix their printer.
Yeah, right.
I'm like, what?
My mom called me last week and had her best friend over, and her best friend's like, my iPad won't connect to my home network. It works at the Apple store. It works at your mom's, but not at my house. I'm like, I'm like, go home and forget the network and add it back again. That's the only thing I've got for you.
Sometimes I like to just hide the fact that I know something about tech. It's sometimes a good time to, when people ask what you do, say you're a poet.
Yeah, exactly.
My
I'm
colleague
starting to
used
learn that one.
Yeah, my colleague used to do that. He said at parties he wouldn't say he was in computers. He would say he's in podiatry or something.
Oh no, say you're a philosophy major.
Yeah, this could be an interesting discussion, right? If you weren't in tech and money didn't matter, what would you say your job was?
I
Pizza
was a
delivery
philosophy.
man.
I was a
Lumberjack.
philosophy major.
Definitely lumberjack.
All right, Jen.
Hey, Jen.
All right, I'm in. It's asking me to choose one screen. Oh wait, desktop. Let's see if it lets me do the whole thing. I'm gonna have to share the whole thing. So is there anything special I have to do?
Nope, just pick a screen and share it.
And then move whatever content you want into that screen.
There we go.
Yay!
Yay.
This is community at work.
Thank you, everyone. This is great. I miss working with people, like, although I guess it's the same. Anyway, so this is Audible. I just wanted to quickly show you that today is Thursday, and Thursday nights, we actually use Audible Live. So tonight you can see Jonathan Altler in conversation with Chris Matthews. If you clicked play, and I'm not going to do it right now because you'll probably hear it as well, but you can see Audible Live streaming through AWS IVS. So practical use for AWS IVS. So the full name is Amazon Interactive Video Service. It's very quick and easy to set up, and I will show you. First thing, you go to Amazon IVS as a service. So if we were to quickly search it, it would take us here. You click Create Channel. So you name it whatever you want, test channel or whatever. Use the default configuration, which is fine. And then pretty much click Create Channel. I already created a channel, so I'm not going to use this. I'm going to use an existing one. When you create a channel, you'll be able to then click on your channel and see a bunch of information, the real-time, the streaming protocol here. One thing to note about this is that it's RTMPS, so it's the secure version. So whatever version of Broadcaster you're using, you want to make sure that it supports RTMPS. It gives you a URL and a stream key. Some applications, you need to concatenate the two of these. I use Open Broadcaster Studio, I think it's called, OBS. It's free and it works great. And it has separate spots for these. And then you have your playback URL here, which is what you put in your browser or your apps or whatnot to let it know to stream what's in this channel. If I click on live channels, you'll see that there is nothing live right now for me. So how do I get it live? Well, I'm glad you asked. The first thing I do, hopefully this shares, is can you see my OBS studio here? Yeah, all right. So that's me. It's the same me that you see in the little window, right? Great. What you do here, very easy, is you go into settings and then you go to stream. You put in that RTMPS URL here, and then here you put your stream key, super easy. And then you just say, okay. And then you say, start streaming. But before we start streaming, we want people to be able to see that we're streaming, right? Of course we do. So you can easily set up a, oh, come on, bud, sorry. You can set up an S3 bucket. And I put it under Gen Hacks here. And create a simple, that's not it. It's under this one here. Create a simple web page. And this one I'll show you here. They give you an example of how to do it under the IVS. Here's the sample. You click on that. It shows you this is what's got to go in the head. You know, here's the style. And then there's JavaScript in here. You just paste it into an HTML page, which I have done here. Except instead of their stream key, you put your stream key. So I put mine right up here. And then you upload that bad boy to an S3 bucket if you want to make it super easy, like I did here. Make sure that your bucket is a web bucket. I just clicked on the wrong thing. So here's your bucket, permissions. I always forget which one. Static web hosting, so you click that, make sure that you have your HTML file here, that that's it, I guess, and make sure it's as well, you go into your folders, make sure that you click on your IVS player or whatever you call it, and then you make sure it's public so people can see it, otherwise it'll say, nope, can't have that. And then if I were to go here right now, you'll see, blank page, nothing is streaming. I can also check that in here under live channels. nothing streaming, nothing streaming. So let's give it a go, eh? All right, shall we start streaming? Click start streaming. There I am. In a moment, under live channels, it will show up. Boom, I'm live. I can click this and you can see me live here. I'm gonna press pause because then you'll be able to hear me there too. And now if I go here, you can see me live on the internet twice, and that was it. How easy was that? So I'm just gonna go away from that and then stop streaming. And another thing that you can do in that is pre-record a video and then stream the pre-recorded video through OBS and connect it to IVS the same way. So it can be live or Memorex and still work. So that was it. Pretty quick, right? Any questions?
Yay!
Fast. And I wanted to make sure I reminded everyone because we're really bad at reminders. So I opened this. AWS reInvent pretty soon will be open for registration. End of October, they say. It's almost there. So here's one of your many reminders. And that's it. I will stop sharing. Brian, over to you, buddy.
Hey, Jen, just before, did you compare this at all to other streaming services, or like, you know, is something you can say about what's good or bad about IVS versus anything else? Other than the fact
What's
that it's AWS?
good about it is it took literally like 3 seconds to figure out, and it gives you the CloudWatch metric. Oh, I should have showed you that. The CloudWatch metrics as well. It's really easy when we're using it for Audible Live. Our marketing people the next day are like, hey, how many people watched it? And I just go in and I grab the metrics of week over week. You know, there are a lot of other, you know, social sharing platforms out there that'll let you share to multiple services, but I like this one because it's in AWS where all of our other stuff is, so you can like, and I showed you the example of setting up one channel. There are ways you could, you know, automate and set up multiple channels. You can, you know, shut off channels. You can rate limit channels. Like, I just like that it's in AWS and it's super easy. So that's my sell.
Yeah, okay, so it's in the ecosystem story is sort of the, if you're, which is good. Just,
and it's not rocket science at all, so.
Right. I had a question. So I was actually looking at using this versus Mux a while back, and I went to Mux because it supported RMTP instead of forcing me to use RMTPS. Do you know if like using RMTPS just requires like putting everything through an SSL tunnel? Like, would that work, or do you know? I don't know. I tried to research it and I couldn't figure that out.
Facebook's using RTMPS now, so that's what we're all using. No, I mean, it's just a secure version of streaming your media. I think it's because, you know, people want to copyright and protect their assets, and it's just another layer of security for people not to hijack your data.
Yeah. Like I couldn't find anything other than OBS that would allow me to do the S version, right? And I was trying to do something like basically like Skype over the phone.
I think Lyric Studio is another one. I had a couple others. If you want to ping me, I can, when I'm on my work computer, I can look and see what the other things were. Cool. OBS was just super easy, and our AV team knew how to use it as well. So
yeah, I can totally use OBS myself, but like, you know, this was trying to get like business people to talk to each other, kind of like Skype in a way, and you know, setting OBS up for business people was not in the plans.
Well, they can Zoom, right?
Yeah.
All right.
Cool.
Fantastic. Well, thanks, Jen. That was fun. Brian, are you all set?
Yep. I'm just going to see if I can play some intro music.
So Brian gets walk-on music.
Damn you.
He got a heads up that I was going to call for it.
Yeah.
Sounds like Doctor Who, but I can't quite hear it.
And it looks like he's playing the harmonica.
Well, that's my ringtone.
So. Dr. Humonica.
Yeah. Okay, let me see. Do my screen share.
And while Brian's just quickly getting set up, to remind people, we do a raffle maybe around 7 o'clock or so with really bad trivia questions to give away $25 Amazon Web Services credit codes. So stick around for that in addition to the awesome content.
Okay, and I'm on multiple screens. Are you actually seeing the CloudFormation Terraform screen?
We're seeing the black screen.
I'm seeing black now. I did see it, but it went away and turned black. There we go.
There it is.
Okay.
Live your scrapbook.
Yeah. All right. I'm going to stop the share and go to a different window because when I play that, it goes to a certain screen. So let me do that, and then do. Okay. Now can you see it?
Yep.
Okay.
Looks good.
Okay, good. Okay, CloudFormation and Terraform. Anyone can ask questions along the way. So this is obligatory branding. I've got a web page. I've got some patents, won some awards, blah blah. Community hero. It may shock all of you to know that I'm one of the organizers of this meetup. I have a Alexa skill called Premier League, and this is the first time that I've remembered to disable Alexa before starting a meeting. So I get at least some points for that. Oh yes, and AWS Heroes. It was great last year at reInvent. They had a booth set up where the newly minted heroes could get their picture taken in front of themselves, which was, I will say, pretty awesome. Okay, so context and such. I will often say CF and TF instead of CloudFormation and Terraform, just because I say those words too much. And I used to be a C programmer, so I'm charged by the character count. I've got a lot of CloudFormation experience. At a previous company, we had about 10,000 lines. Sorry, 50,000 lines. Ha! I wish it was 10,000. Less than a year of Terraform, but pretty deep into it. The last bullet was sort of the, at a certain level, we pretend that everything is just Amazon, but there is the hybrid cloud and multi-cloud, and that can be a push towards Terraform if you want it to be. But you can also use Terraform even if you are all in with AWS. Okay, so this is our agenda. We're going to go through the overview. We're going to start looking at simple stuff first, and then how you parameterize everything, how you actually deploy it, how things start working in the large, and then what is truth, which seems very appropriate these days as a notion.
Hey, Brian.
Yep.
Before you dive in, do you want people to hold questions or interrupt as they have things as you go?
You can interrupt.
Okay.
And Ken, I'm going to hope that you will keep an eye on the chat because I can't right now.
I will do my best.
Okay. All right.
I'll help.
Okay. Excellent. So the overview. If you're not familiar with CloudFormation, then you haven't been on the DevOps side of things. But it's basically how we orchestrate creating things in the cloud. EC2 instances, S3 buckets, so on. I'm sure that IVS, whatever Jenn just showed, will probably have CloudFormation support tomorrow or already. And Terraform is the cloud agnostic system that can do not just Amazon, but also Google and Azure and all kinds of things. Actually, it has a plugin infrastructure. And all of this is based on the notion that infrastructure is code. Whether it's YAML or JSON, I don't care, pick your poison. I would as soon get into the YAML versus JSON argument as I would argue where the braces should go at the end of the line. I'm not touching that. but infrastructure as code is a good thing. It's a good thing, like puppies, okay? Or cats, it's a good thing. It's a very good thing. So just a glossary to get us started on terms. So the resources are the actual things. If you're spinning up an EC2 instance, that's a resource. If you're creating a bucket, that's a resource. I'm sure if you created a streaming IVS streams, that's a resource. That's a thing. A stack is a group of things in CloudFormation land, and you get that group of things through a template. And the templates are the thing that should be in source code. When you build a template, you copy it out to S3, and you always deploy from S3. Okay, that's CloudFormation. In Terraform, it's basically the same thing, but with some different names. So the modules are the collections of resources. You make a plan to make your reality change to the state that you're asking for. Well, plan actually says what it would do. Apply actually does it. And the state is the cached information about the resources. Now, CloudFormation also has state, but we don't generally talk about it because state in CloudFormation lives inside the CloudFormation service. So, and we'll talk about that later. And so you don't really see the state per se, but in Terraform, state is essentially a first-class object, and you can look at the state, you can play with it. Be careful when you do that. There are all kinds of operations that can get you into trouble, but we'll get into that later. And then variables are the values that you pass into a state to parameterize it, which is why in CloudFormation they're called parameters. So let's look at some basic resources. Okay. Every type of resource has different things in it. Think about, what's the commonalities between, a bucket and an EC2 instance and a Dynamo database. There's all kinds of differences. And for each thing, you have to learn what are the properties that you need to specify. The docs, the Amazon docs are quite good at describing individual objects. They're a little less good about all the implications and back and forths of those objects. So for example, each property has a value of, if you change that property, will it require a change in the object itself? And so some things you can change about a resource without changing the resource. Some things in a resource, if you change the value, you tear one down and make a new one. And that's totally dependent on each resource. And the documentation is okay about that, but there are places where you can get bit. And that can be an issue if you think you're just updating a parameter of an object and it tears it down and spins a new one up, and maybe you've lost some data or it gets a new ID or so on. So that's something to pay attention to. This is an example of a very simple CloudFormation template. It always starts with the template version. It's great to have a description, and then you have resources, and then all your resources you list, under there. The first line, let's see, can I? Oh, yeah, I can. Okay, so this is the name that the resource is given, and this is how you can refer to it within the stack. And then this is the type, and then you have all the various properties. So different people have different ideas about how to name things. I tend to include the type inside the name. So if I'm looking at it later, latency topic, it's a topic, I tend to go for no surprises. Okay. This is a Terraform simple resource. It takes a slightly different approach. Instead of having a resource section and then everything under there is a resource, in Terraform, you specify everything, as a resource. And here, this is the type. and this is the name. And you can see that Terraform tends to be a little more terse. You know, it doesn't say the type is AWS 3-bucket. It's just, it's AWS 3-bucket, and it's in the first spot, so that's the type. And then, you know, just substituting the various parameters that you might use for S3. So they're very similar, but there are, you know, there are some differences. This is just a random example of multiple resources. You only say resources once. This is a topic. This is a role. You know, you can have relationships between them, but you just, you know, just list them all. As you get into larger scales, as opposed to just individual, you know, fairly small stacks, you can have all kinds of conversations, and your group should have conversations about groupings. You know, should all the topics be together in one file? Should all the roles be together in one file? Or should the role go along with the topic? These are both fine approaches, but, you know, they're approaches that you should be figuring out ahead of time, because these files tend to proliferate. And remember, at the beginning I said we had 50,000 lines of CloudFormation at one of my last companies. 50,000 lines of code like this can get overwhelming unless you have a strategy for organizing them. This is just an example of a very similar thing in Terraform. Again, this is a role. That's the name of the role. You know, here we have the policy that goes with the role, and here we have, you know, a policy attachment. You can see here that I'm referring to, down here, I'm referring to the role that I created up here. And one of the things that I actually quite like about Terraform, it's kind of a safety feature, is that within this file, there's only one thing called a Lambda role. And so down here, I could, I mean, Terraform doesn't let you, but conceptually, you could have said, well, why do I need to say that it's a role? It is a Lambda role. But I like this protection that Lambda, or the Terraform, makes you say, yep, it's a role, and it's this one, and it's the name. So it just gives you an extra level of protection there. This eye chart is a very, very old partial list of all the resources that CloudFormation and by extension Terraform supports. At this point, there's something like 620 resources. Nobody knows them all. This was actually one of the things I noticed about this screen, is that you can see the items that are in orange are the ones that I've dived into and looked, and mostly I haven't. But this was my actual a screenshot from my actual, you know, live system. So you will only ever know a fraction of the resources. But the ones you do know, the ones you need to know, dive in and you'll get everything you need to know about them. This is just another example of sort of showing that different resources have vastly different sets of properties. I don't think that there's any property that's the same across both of these items. And so you can learn Terraform or CloudFormation in general, but then you have to dive in and learn what each of the individual things mean. And lots of these parameters are optional or have defaults. You can make your own decision about whether you want to specify the defaults. Again, that's a stylistic thing.
Hey, Brian, can I interrupt?
Of course.
So intuitively, right, these are just abstractions on top of the AWS API for these. So what do you think is the reason why there are differences? Is it that, for example, CloudFormation isn't supporting, as in some cases, as many of the attributes, or are they meta attributes? So you know what I'm saying?
Well, let's see. It's interesting because there's the CloudFormation description of a resource. There's the Bodo or command line description of the object, and then there's what you can do in the console. And one of the things I'll find is if I get confused, I'll go back and forth amongst them to try to find different information. The console, and different people are bringing different experiences to the game. A lot of people are just doing things in the console. Console will often do multiple resources at a time, and so then you have to tease them apart. And even the command line will sometimes do multiple things at a time for you. Whereas in CloudFormation, I believe it's more fine grained, and so they let you do individual pieces at a lower level than the console would.
No, I think I misunderstood what you're saying. So my question was actually, I thought what you were saying is comparing CloudFormation to Terraform, and that's why I was asking. Sorry, I ignore me.
Okay.
Because I couldn't. But yeah, okay.
The CloudFormation and Terraform, in general, map 1-to-1. In general.
Yeah. Okay. Sorry, I misunderstood.
Okay.
Never mind me.
Okay. Because remember, under the covers, both CloudFormation and Terraform are making API calls. So.
Right. Well, that's why I was surprised that they were saying that there were differences in that. Yeah. Okay.
Yeah. Okay. No, that's cool. That's cool. Okay, so parameters. Your infrastructure has to have parameters, or else you can only use it once, and that would be silly. And CloudFormation calls them parameters. Terraform calls them variables. And again, it's a good thing. Sorry, I just love my dogs, and it's just okay. So in CloudFormation, you have a separate parameter section. So you have resource section, you have parameter sections. For each parameter, you say you give it a name, its type. You probably should give a description. You don't have to. You can give default values. You can give allowed values. You can go to town, and then down in the resources, you use them. And so I'll get two examples here, which are kind of interesting. So topic name, you say bang ref topic name because you're referring to the topic name. And this bang syntax is short for FN : reference or something. Nobody uses the long version. I've never used the long version. So I'm referring to a thing. And then down here in subscription, here's an email. And here I'm substituting that value in. And so CloudFormation makes you be explicit about I'm referring to the whole thing, or I'm just building up a string that part of it is hard-coded and part of it is coming in from a parameter. Okay. In the Terraform example, it follows the same pattern of a little bit more terse. So here we have a resource that's an AWS bucket, and it's called my bucket. And the name comes in from the variable context and instance. And we'll get into how you actually get that. But this is essentially how you pass in a parameter. But you notice there's no function here. It doesn't say, substitute that in here. It's just implied. Because what else would you do? You substitute it in. And so you can either, depending on your point of view, say, that's too terse, or you can think that CloudFormation is a little too verbose. Okay, but pretty much any place you need a variable, you can just stick it inside this style, and it will substitute it in. Okay, so now let's suppose we've got some templates either in CF or TF, and we want to run them. In Terraform, you run a plan. And the plan will tell you what it's going to do. It's essentially like a make n or a dry run command. It'll go through all the steps of deploying what you have compared to what's out there, and it would tell you all the things that it would do. It'll tell you, I'm going to replace this, I'm going to create this, I'm going to delete this. And it will even tell you for each object that if it's updating an object for each object, it will indicate which one of the parameters are changing so that you can know why we had to change that. You can save the plan and then run apply against the plan to actually actually make those changes happen, or you can just run apply again. Mostly we tend to run apply, although, you know, depending on your CI/CD point of view, if you had stored a plan, some time may have gone by. You know, it's up to you to decide: am I running the apply soon enough after I did a plan that no one else has changed anything? In CloudFormation, you can do a somewhat similar thing in that you can say deploy the CloudFormation stack directly, or you can create what's called a change set. And the change set will show you a similar version of what will I do if you apply this change set. Although there are some differences that we're going to get into in a second. And here's where we start to get into where the real differences are between the system. But so in Terraform, it's plan and apply. In CloudFormation, it's deploy or change set. And this goes then to the question, what is truth? So here's an example. Suppose we have a template file and CloudFormation and an auto-scaling group. And this is in CloudFormation. So I set my auto-scaling group to size 2. Okay, great. And CloudFormation says, yep, that's auto-scaling group of size 2. And lo and behold, we've created an auto-scaling group of size 2. Everything's lovely. Then one of your developers or ops people go in and they change the auto-scaling group to 3 without going through the whole system. And now you know that someone has put it to 3 and you want the auto-scaling group to be back to 2. So you say, apply the CloudFormation template again. Well, it looks at CloudFormation and it says there's nothing to do, and it does not change it. And you can run drift detection, and drift detection will say, hey, the state of your stack is different than the reality, but then it doesn't actually do anything about it. And in this case, what you're left to do is to change the template to 3, let it deploy, it'll change this to 3, and then it'll say, oh, I have 3, if you're lucky. And then you set it back to 2. But that's sort of that's a pretty convoluted way to do it. You don't really have item potency. You can't just run it again. In Terraform, if we had Terraform and the ASG and a template again, we set it to 2, we set it to 2, we get 2. Now someone goes and changes it to 3, cool. And now I want to run Terraform plan again. Okay, I say apply. The first thing it does is refreshes the state from reality. Okay, the Terraform state now becomes 3. Then it says, hey, the Terraform state is 3 and that's accurate, and you've asked for 2, so I'm going to update it to 2. And so it changes it to 2. And I think I skipped making the middle guy go back from 3 to 2. So we'll just jump over that quickly and pretend that I didn't make that mistake. But the point is that Terraform is more item potent. And if you say, make it be so, it will make it be so whether it's that way or not. And so in my mind, that's a pretty large win of Terraform. Okay. So, and this all comes from the fact that Terraform keeps its state internally. You don't have access to it. It's just part of the service. Terraform, you keep the state someplace. Very often it's in an S3 bucket or a GCP storage. I think they call storage buckets as well. And when I first was learning about Terraform, I thought this was a really bad idea because, oh my God, I could lose the file. I could corrupt the file. All kinds of things could happen to the file. And that's true. If you allow people access to the state file, it's just a human readable file, and you can muck with it if you want to. And so there's a danger. So don't do that. I mean, this is part of your jewels. If it's in S3, protect your S3. Have versioning. Have versioning. But you get some capabilities that you don't get with CloudFormation. You can look at the state. There are times when you need to know what's going on, and you can actually look at the state. You can modify the state. And the other thing that Terraform has a real advantage of is that you can import the state from manual resources. Now, CloudFormation lets you do that a little bit, and I think I actually have another slide about that. Right. So one of the things that becomes really easy in Terraform is that although we say infrastructure, all infrastructure is code, the reality is that there are times when we want to muck about in the console. We're doing pathfinding, we're exploring. And so we create things in the console. We might create a bunch of things and we get the system working, and that's what we want. And then it's, hey, I wish I had the infrastructure as code that would let me create that. In CloudFormation can recently added or about a year ago, added the capability to create a stack from existing resources. But of the 625 or so resources available, it can only import about 6. Maybe it's 10 now. Eventually, it will be most of them. But Terraform can import just about anything. So there have been times when I haven't been able to figure out the Terraform documentation on how to do a particular thing. I go do the thing in the console, and then I import the resource, and it gives me the resulting code. And so that's pretty handy. That's a real win. Okay, pause, questions? Okay, carrying on. Resource grouping. It's very seldom that you're deploying, 6 resources or 10 resources or 20. By the time in any realistic system, you're likely to be deploying hundreds of resources of different types. And the question is, how do you know what the dependencies are between them? How do you group them? How do you handle the case where I might want to be deploying some of them and not other ones? CloudFormation has a limit on the number of resources per file. I think it's like 200 or 600. I mean, it's a number that's fairly large, but it's not crazy large. CloudFormation approaches this with nested stacks, so you can do multiple stacks or even the big giant stack. And Terraform has modules. So let's look at how the two systems approach this kind of problem. So in CloudFormation, a stack is just a resource, which is actually pretty cool. It's a resource like any other resource. You can see right here, I've got a real-time broker stack, and its type is stack. It's like, okay, great. And I have my template URL that points to where on S3 that stack is. And so this creates a nested stack within the top level stack. And it's just a resource. You can intermix them any way you want. And that's pretty cool. So top level stack can create as many underlying stacks as you want. You can go to a third level of nesting. I actually don't think, I've never encountered anyone who, I'll put it this way, I've never encountered anyone who's hit what the maximum level of nesting is. I would hope that there is some maximum level. I've never seen anyone go beyond 3 levels. It gets to be pretty nasty. So use that with caution. When you create a nested stack, you can bubble information up to the other stacks. You can also bubble information up, when you create a nested stack, you can bubble information up to the parent stack. You can also bubble information up so that any stack can find that information. I'll show you that in a sec. There's an output section, just like we had parameters and resources. There's an output section where you can send information out of the stack. If you output it, it's just available to the parent. If you export it, it's available to other stacks in the region. So I'll show you that. Here I've got an output. I've got the ID of some resource that's inside the stack. This value gets passed to the parent. This value gets exposed to everybody else. So there's a way to tie things together. And so what we've sometimes seen is a top-level stack will have, auto-scaling groups, and you might have a nested auto-scaling group because you want all your auto-scaling groups to look the same. And so lots of top-level stacks can share that ASG, and then the ASG might output its ARN so that other people can use it. Okay. Now there's some problems. There's some caveats to nested stacks. remember when we talked about change sets, and if I want to see what is going to happen to my stack if I apply it, anytime, sorry? Okay. Anytime I ask for a change set on a nested stack, it's going to tell me, hey, I might have to change this nested stack. But it doesn't go through and tell you if it actually would or not. So if you're in an environment where you have lots of nested stacks, change set capability becomes kind of useless. You're also told that you shouldn't invoke a nested stack on its own. There's nothing that actually prevents you from doing that. But if you do that, then the parent stack doesn't know about the change. And that's a problem. And so you really can't do anything except invoke the entire stack as a monolith. And that's a problem. And also drift detection, just like change set, drift detection won't tell you what has changed in the nested stacks. That's probably something that's going to be fixed at some point. I know that there's a roadmap for that, but right now that doesn't exist. So these are all substantial problems for change sets. Sorry, for nested stacks. In Terraform, there's a notion of module, and this to me feels like a much more of a first-class citizen. So every Terraform really has three parts. There's your main.tf, and you can name these anything you want, but I tend to go with the if you use different names, then you have to specify more parameters. But typically, in each directory, you'll have a main TF that the actual resources is going to be created. You'll have variables, which tells you what's going into the main, and then you'll have outputs, which tells you what's coming out of the main. So you'll very often see a directory structure with these three files, and just there's really no reason to change the names. Okay. And so this is a very typical directory structure for a Terraform deploy. And you can see that this is part of a system because it starts with AWS because this was copied from a system that also had Azure and GCP. But under AWS, I have modules. And then you can see here I've got everything about gateway, API gateway, and it's my main, output, and variables. You know, everything about creating DynamoDB, main and outputs. This particular one doesn't take any variables. You can see this pattern is created over and over and over again. And you might ask, where did the variables originally come from? Well, there's a special file called tfvars that's at the top level, and that's where your variables actually come from. And that's the initial input. And so your Terraform vars plus your variable files go into your whatever main.tf file you have, and that's how you get all the actual values that you're going to use. So to me, this is a very logical approach. There's no level of nesting that's essentially too much. Again, there's different styles. You know, in this approach, you know, all our roles and policies are here in the IAM group, and then they're used elsewhere. You can say, I don't want to do it that way. You can say that, you know, everything for Lambda should be, you know, under Lambda. So in that case, you know, all my Lambda roles would be defined in Lambdas. You can do either one of those. The point is that you follow this pattern, and then you have a structure where you can pass all the information around, and you can deploy the individual pieces as you like. And I'll show you that in just a sec. But here's an example. This is a TF var files. I'm saying these are some question. Okay, these are some values that I might have inside inside the TFRs. Then I have a variables file, and you can see that, you know, the region comes over here into region. You know, for AWS, the region comes over here into region. So AWS.region is US East-1. GCP.region is US East or US-East 1. And I don't know why GCP decided to follow the exact pattern except for the final dash, but so be it. And then here's an actual main.tf, and here we see that the context is var.context, and region is var AWS region. So it's pretty easy to follow how you get the information flowing amongst the systems, and region is region. Targeting is where some of the real power comes in that whereas in CloudFormation, you can only deploy the whole stack, in Terraform, you can deploy any part of the stack that you want. So normally you might just say TF plan, or you could say TF plan module AWS. So if I wanted to make absolutely sure that I wasn't going to be deploying anything in GCP or Azure, I'd do module AWS. Now, it can be both a safety thing and a time thing, in that if you had not made any changes in Azure and GCP, Terraform would figure that out and it wouldn't do anything, but it would take it a little while for it to figure out, especially because since it's going back to truth, it has to interrogate the whole stack, figure out if there's any change, and then say, okay, there's no changes. So it can be a speed thing, but it also can be a safety thing. If I'm in a situation where I'm playing with some lambdas and I know I'm not touching anything else, I can just say, hey, update my lambdas. And then I know for certain both it'll be quick and it will just update those things. And you can put multiple levels of targeting in. One gotcha I will tell you about is that if you make any misspellings here, because this follows a directory pattern, so this will look in AWS/module/lambda. Well, if I made this modules, for example, instead, there is no lambda under modules. Terraform doesn't give you an error. It just says, oh, there's nothing to do. And so we've all been bit by that before where, I made some changes, I was pretty sure I put things back. I really didn't make any changes. I ran a plan targeting and it said I didn't make any changes. And then I check it in and it turns out I had misspelled modules and I'd made all kinds of changes. So that's, if I had one gripe about Terraform, I think it really should say directory not found. I mean, come on, it figured that out. But anyway. So the nested stacks versus modules comparison. There's not really good change test support. You can't invoke things individually, and nested stacks are limited. So this was really the thing that pushed me over the edge for Terraform, because you want modularity. If we're really going to say that infrastructure is code, it should be good code. So, and you can have top-level stacks. I mean, you can't avoid the nested stack problem by just having multiple top-level stacks, but that's just squeezing the bubble. And this is in fact what we did at another company. We had 30 top-level stacks, and we talked to Amazon, and at one point they suggested, well, why don't you make an Uber stack? And we actually had the Uber stack project to create a stack on top of all the other stacks. But then the problem was CloudFormation doesn't know about the existing stacks, and so we would have to recreate them. And for databases, that's a real problem. And create stack from resources is a partial solution, but there isn't full enough support for that. So what we ended up doing was writing an Ansible playbook layer on top of the whole thing. And normally you think of Ansible as, I'm going to run a command against a whole bunch of EC2 instances, and you have the Ansible inventory. And we did something completely different, which I thought was very cool. Wasn't my idea, but still think it was very cool, where our playbooks were just CloudFormation stacks. And so each Ansible playbook corresponded to a top-level stack, and then we had a top-level playbook that would run all the other playbooks, and we had var files, and everything was checked in, and that was lovely. Another approach is big giant stack, and it sort of boggles my mind that that's an acceptable alternate answer. Denormalization is okay, but that just, I mean, copy and paste is not. It's like, come on, it's 2020. We're better than that. So Now, one of my favorite topics is custom resources. CloudFormation can do just about anything that Amazon as a whole can do. There's I think Amazon calls it day one. You know, everything's day one, so everything should be ready day one. If there's a new service, CloudFormation should support it. And that's almost always true. But it's true except when it isn't. And CloudFormation gives you this wonderful escape mechanism, which is custom resources. So I know there's another type of custom resource that isn't Lambda backed, but I've never used them, and I don't know why you would. But I'm a Lambda proponent, I guess I'll say, to be kind. But when you create a resource in CloudFormation, there's a create event, there's an update event, and there's a delete event. And in a custom resource, you just write a Lambda that handles those events and does whatever you want. And this is useful if the resource you want isn't supported by CloudFormation. In particular, it can do things like CloudFormation lets you create databases, but it doesn't let you do inserts into the databases or creating indexes or anything like that. If you need to do that, you can do those in a Lambda resource.
Brian,
Yep.
I think it's fair to say, or tell me if things have changed since I last tried it. The Lambda custom resources, if you fail your Lambda function because you got a bug or something doesn't happen, it's a real nightmare. Because you can't work with your stack until it times out.
Yeah, that's the next slide.
Oh, yeah.
But that's okay. That's okay. Right. So clearly Ken has gone through the pain. Your resource has to make a very specific call with a very specific value, or the thing hangs. If it hangs for 4 hours, and there's nothing you can do. There's nothing Amazon can do. We have tried. There is a time where when you delete an S3 bucket in CloudFormation, it fails unless the bucket is empty, which I think is crazy, but so be it. And so one of the people on my team wrote a custom backed Lambda that would delete the bucket. And they didn't change the default timeout. And the default timeout was 6 seconds. And this bucket had, a couple 100,000 items in it. And so it's 2 a.m. one fine day, and we're doing a deploy, and the deploy is stuck. And come to find out that the Lambda, the custom back resource Lambda, has timed out and failed, and the stack is stuck. And so at 2 a.m, I get to tell my VP that we'll be able to resume at 6 o'clock in the morning, and there is nothing that can be done. This is one place where copy and paste is good. Find an example and copy and paste it, because you don't want to make the mistake. And well, that error couldn't happen in my Python. Yes, it can. And there's and it can time out. So be aware of that. And I'll just back to the previous slide and say one thing. So you can escape from CloudFormation into Lambda. You can also escape from Terraform into CloudFormation. And so we actually, at my last company, we found a thing that was supported by CF that wasn't supported by TF. So I created a CF stack inside a TF resource that created a stack that just created this one resource. And I told them what I really wanted to do was go escape from TF into CF and then from CF into Lambda, just because I could. And they said, go home and do that on your own time. But so it's kind of cool. So custom resources are really, really cool. Don't mess them up, or else you're going to have 4 hours of shame. Conditionals. So in CloudFormation, you can do conditionals. So over here, I've got a parameter. I might have what kind of environment, dev test prod, blah blah blah. And down here in my actual CloudFormation file, I want to create different things based on what environment I'm in. So what I have to do is I create a condition. And so here I say, I guess I did use this. This is the bigger secret. bigger syntax, FN : equals. To me, that's a long way to spell equals, but anyway. So you can say this prod notify condition is true if the environment is prod. Excuse me. Then down here, you actually say, not if it's prod, use no value and the key pair. And I just love the amount of negation that's going on in here. But this isn't negation, and that's not negation, but that is negation. So I always think of bang as, anyway, blah, blah, blah. Language theory. So you can do these conditionals, but you can do equality tests against parameters, but you have to go through this intermediary step of creating a condition. In Terraform, it's simpler. You say, do I want to override the private IP? My default value, my default value of this variable is null. So if I don't specify it, Terraform just knows that, hey, this critter didn't get a value. It's defaulting to null, so I'm not going to use it. So again, it's just a simplicity. I like just saying it's null, so don't use it, rather than have a 3-step process. And so, in summary, I used to be a CloudFormation cheerleader. 2 years ago, I gave an AWS Community Days talk on tips and tricks for CloudFormation, and I think at this point, my tip and trick for CloudFormation is use Terraform. So that's it. And the timing is just about right. Questions?
Brian, you didn't talk any about config files in Terraform as kind of a utilization of your variables. So I'm curious your thoughts on that structure.
Okay. Now, are you talking about? It's funny because I'm thinking about mostly for variables. Are you thinking about config files for the actual configuration of Terraform itself?
Yeah, no, I'm thinking so the use case of, dev, test, production, right? And you've got different target environments for each, for example, and you don't want people calling that at the command line, right? You want them to call it with a config file, and it says when you're ready to push to production, and that's part of your your source control, you call it against this config file, and it repoints and pushes everything there.
Sure. I see where you're going. Yeah, and I'll say at my last company we had I think a very interesting approach to this, in that we had different customers in different environments that had different variables. Some was just configuration that wasn't so important, but some of it was actual secret information. So what we did was we had our main, but we wanted the Terraform, the vast majority of Terraform to be common across all the customers. So we had one repository for all the Terraform files except for the TFR files. And then we had repos per customer for the TFR files. And so when you wanted to deploy to a particular customer, you could only do it if you had been granted access to the repo for that customer. And then when you ran it, you would say TF apply, and then .. directory to the particular customer's TFRs, and that worked quite well, especially because we had offshore resources that weren't allowed to use to see any of those things, and we were able to use Git as our boundaries.
Okay. Yeah. So I mean, that's kind of validating the option there. I'm just thinking there's you develop a code base of Terraform, and I was curious if there was an equivalent in CloudFormation, or because that design pattern in Terraform seemed to be really powerful, and not just in the dev test prod, but if you've got, you know, variations and you're going to deploy a specific variation for this. And so I'm thinking, in my world, we do a lot of, we need to be able to reproduce the analysis that was done with a particular version of code. So if we wanted, we're still deploying to production, but now we're deploying a specific set of resources that was utilized 2 years ago or whatever, and we're going to redo that analysis, right? So that scenario, we can capture what was deployed and the attributes related to that without having to create a whole nother fork of code, so to speak.
Right. Now, in CloudFormation, lets you get the parameters from a source code file. Since we ended up writing an Ansible playbook layer, on top, the basically that was the source of truth for the variables. So the Ansible playbook vars were again per customer. At that company, we didn't put them in separate repos, but we put them in separate directories, separate trees of the same repo, so that we could do exactly what you said. So that if we want to go to customer X, what was deployed on 6 months ago, we could go exactly to the Ansible playbook vars, check that branch out, and do the deploy, and we'd get exactly that.
Right. Okay.
And you can do that without Ansible. I mean, you can do that just using var files for parameters.
Right.
We didn't need to do that, but you
Right.
certainly can.
Okay. And then the next thing that I wanted to ask about was, you didn't talk too much about, I mean, so this is focused on the infrastructure side of things, but sometimes you got to get inside the infrastructure that you're deploying, and you need to do a kickoff script or something in order to actually provision the resource internally that's not exposed through the Amazon API or whoever you're deploying to. We won't name anybody else because nobody else exists, right?
Sure, and it's funny, as you ask that question, I'm looking in the chat, and Ashit is saying that they basically doing database CRUD using a declarative language might be crazy, and it's certainly possible. I mean, there's lots of ways. There's lots of ways you can do that. You can have you could have lambdas that were triggered by CloudFormation. CloudWatch events. So you could say, once a certain CloudWatch event occurs, it tells me that everything is up and deployed. Just run some lambda to go do whatever initialization you want. That's certainly a fine approach. I mean, you can do, if you're doing EC2, you can do user data scripts. Those are not for the faint of heart, but they're pretty cool. But I mean, these days, and I should be saying Event Bridge instead of CloudWatch Event, even though for right now they're the same thing. But Event Bridge calling in Lambda is your general escape to do anything.
Right. Okay. And then in Terraform also has some limited ability to kick off a script or insert the user space scripts as well in in EC2 or
oh yeah. Oh yeah. Absolutely.
Right. Okay.
Brian, there was a question in the chat a long time ago, essentially asking what tools, resources exist to transform between CloudFormation and Terraform, or maybe the other way around. I don't recall who actually asked if they want to amplify that.
I would be shocked if there wasn't some third-party tool. Although I've got, okay. And so here's a caveat. I should have probably said it at the very beginning. The unnamed player in this whole thing is the CDK, in that Amazon has write code to do your infrastructure as opposed to declarative. And I've got a hero friend who is always sort of after me. It's like, Brian, why don't you do CDK? And it's like, I should and I will, but when CDK came first started, you know, it was pretty new, and I'm also not entirely sure. I mean, there's an interesting question: should infrastructure be provisioned declaratively or imperatively? And I don't know. I mean, it's not at all clear to me that I want to run. I mean, I certainly could. I mean, by definition, I could write a bunch of Python code that's just called the API to do things. And I mean, at a certain level, CDK is that, but helping me out, you know, with all kinds of shortcuts.
It depends, right, on how dynamic the infrastructure is, right? If it's really static, then declarative sort of fits. If you've got some weird thing that's, you know, highly parameterized and scales in different shapes and ways and things that, you know, you might want to use some more imperative-like logic, then, you know, then that's where CDK can be easier. I mean, I think it has to do with the nature of what you're actually deploying as opposed to what tool is best.
Right.
Exactly.
The one other thing, oh, go ahead, whoever.
Sorry, no, that's exactly, Ken gets the point. That's exactly what I was going to add. Declarative for the most part is fine. Imperative, you know, if you need some error handling, some logic handlers, then for those specialized use cases, imperative certainly matters. And that's what I'm saying, right? There's nothing that prevents you from having logic handlers, having Lambda execute within, being called from within a declarative utility like a Terraform or CloudFormation.
Right, absolutely. I mean, use the right tool for the job. The thing I was gonna say is that as systems get large and complex, then the dependencies get pretty interesting. A real power of both CloudFormation and Terraform is you say, go apply or deploy, and they will figure out, with a few exceptions, they'll figure out what the dependency graph is and what has to be deployed in what order. And I'll confess that I don't know how CDK handles that. Now, both Terraform and CloudFormation do allow you to put in a depends on parameter in case the system can't tell. But in general, it figures it out. The other thing I'll mention for both of them is that there are Amazon resources should not report that they're ready until they're ready. Take it as a statement of fact. But some of them don't do that, especially API Gateway tends to report that things are ready when it's not ready. And so so in Terraform, we've actually had to have what we typically called the null resource, where that resource was satisfied with, oh my God, a sleep, which is, you know, appalling. But if you know, if gateway comes up and you have dependent, you know, a gateway is a complex beast, and if part of it comes up but isn't really ready, you can run into problems. To be honest, I'm not sure how CDK handles that.
Well, one thing just to be aware of, I'm not sure if it totally answers your question, but ultimately CDK is still just spitting out CloudFormation, right?
Yep, yeah.
So it's a way, it's almost like a macro layer, if you can think about it that way, that, you know, it pre-compiles your logic into this nice flat static declarative thing. Hey, Brian, before we get too far in, we can ask, you know, obviously as long as people want to hang out and as long as you're awake, we can have more questions, but do you want to do the raffle before we lose everybody?
Sure, go ahead, and I would say you're the host, man, do the raffle.
Okay. Hey, well, do you have the
I have questions.
Okay, and so the way this works is Jen will ask a question and then type your answer in chat. First one wins. If you're the winner, send an email to me, Brian Tarbox @gmail.com. And there actually is a winner from last week that I have been so bad. I still owe you a response. I have you in my email queue. I've just been I've been on 800 interviews these last 2 weeks.
They get interest.
What?
They get interest credits.
Yeah.
It's up to
yeah.
$27 now.
Okay, so
all right,
go ahead.
So Jen, you got the questions then. All right.
Where are you investing? I want those kind of returns.
All right, here we go. Which AWS service is having a track or treat challenge this October? Track or treat?
Type it into the chat. First one in wins that coveted $25 credits.
Oh, we got it.
Winner.
Tony?
Excellent.
And I will copy the link and paste it in here if anyone's interested in checking out the track or treat challenge. There it is.
And so Tony, send me an email to Brian Tarbox at Gmail and just mention the meetup.
Right. So we had Brian, we have one more gift card.
Yeah. Oh yeah.
And we have.
I have 75 more questions if you want me
Oh,
to
you
ask
do?
them.
Okay. So I was looking at our list. All right, Jen, fire away.
All right. Let's say you're a ghost hunter. Which gadget would you use to detect ghosts?
Everyone should notice that we're Halloween themed here. Thank you, Jen. CloudWatch. Oh, I think CloudWatch gets some points.
Oh, PKE meter was what I was thinking.
Yep.
That's the answer, although I do love the CloudWatch answer.
Yeah, that was great. That was perfect. Will
we get bonus points for that? Just so you know, originality.
Give me one sec. Let me just see how many. We got extras. Who said the CloudWatch?
The first CloudWatch?
Mohammed?
Well, it would be Roger, I think, was the first CloudWatch for that one.
Yeah, we got a lot of CloudWatches.
Okay, Roger, send me. I have extras. Roger, just because that was just so damn funny. Send me an email and we'll give you one.
Thank you.
That was awesome. So now we have two answers for any future contest. It's either 42 or CloudWatch. Just remember that, and then we'll be all set.
Right. And I'll say,
Jen, your next question needs to be question 42 on your list.
Oh, my list stops at 41.
Oh, come on.
Yep. And I will tell people that we don't have it. I don't have it posted yet, but the meeting in 2 weeks is going to be with Gunnar Grosch, who is going to tell us some awesomeness about serverless, and he hasn't decided which awesomeness it is, but he is an amazing speaker and who actually just transitioned from being a serverless hero to an AWS developer advocate.
Awesome. Yeah, he's the real deal.
Yeah.
Okay, so we're at 7:22 on my clock, at least in the East Coast here. We have people at different time zones. If there are more questions, Brian, you willing to answer a few more?
Sure.
Or if not, we can wrap. Anyone else have any more questions or thoughts?
Everyone stay safe.
All right. Fantastic. Well, this is I really appreciate that presentation, Brian. I think it was really interesting and informative. Good to kind of get some multiple perspectives all at once, which is instead of just sometimes we get this sort of down the straight, one product, one perspective. So that was really neat. And Jen, that was always fun as usual. So good session, and Roger, bring it.
Yeah, absolutely.
So thanks everyone. Keep an eye out for the next meetup with Gunnar and the ones that follow. Hope everyone had a good time. Appreciate everyone's attendance, and we'll see you next time.
And if anyone has a very short demo that they want to do at the beginning of any one of these, like that's a fun way to kick these off, I think.
Demo or lightning talk or anything,
yeah,
right?
absolutely. Because just as Chris was saying, doing a brown bucket, whatever thing he said, is great on your resume. Right. If you give a 5-minute lightning talk, you have a presentation, and that's a section on your resume, and we will back you up on that.
It's always good experience and fun for everyone. So it doesn't matter how polished it is. I think we're obviously an accessible community here. So good, safe place. All right. Thanks everyone. See you next time, hopefully.
All right.
Halloween.
Have a good
Cheers.
night.
Happy Halloween. Jen, are you putting out candy?